Let us now continue our discussion on the chapter of polynomials. And in the previous video, we have seen the remainder theorem and the factor theorem, and how to check whether a monomial is a factor of another polynomial or not. And we also saw how to find the zeros of that polynomial as well. Now let us look at another way of factorizing a polynomial p of x, and this method is called factorization by splitting the middle term. So if you look at this term, look at this polynomial, there is a term with the power of 2, okay, that's x square, and there is a term with the power of 1, and there's a term with the power of 0. So the highest power here is 2, so therefore this is a quadratic polynomial. And this method of factorization by splitting the middle term is used for factorizing quadratic polynomials. So what the procedure is, what we have to do in this procedure is that we have to split this middle term, which is the term with containing only the x power 1. We have to split this in a specific way, and after that we'll apply some basic algebra to simplify the expression, and then we will have our factorization completed. So what is the method of splitting this middle term? So what we have to basically do is, this is a polynomial which takes the general form of ax squared plus bx plus c. So in this case, a is 6, b is 17, and c is 5. So it's ax squared plus bx plus c. So splitting the middle term here involves writing this middle term in terms of two different numbers. So the middle term is 17, and we have to split that middle term, which is having a value of 17, by two different numbers, and those two different numbers that we choose should be such that their product should be equal to the product of a and c. So a is here 6 and c is 5. So a into c is 6 into 5, so it's 30. So we need to split the number 17 into two parts such that those two parts have a product of 30, and when you add those two parts, it should give us 17. So what are the numbers which can have a product of 30, and when we add them algebraically, we should get plus 17, and plus 30 should be the product. The product of 30 can be obtained as 6 into 5, but 6 plus 5 is not 17, so therefore we can't use 6 and 5. The other way of getting 30 as a product of two numbers is 10 and 3. 10 into 3 will give us 30, but 10 plus 3 will give us only 13 and not 17, so we can't use 10 and 3. The other way is say 15 and 2, so that should work, because 15 into, let me write that as 2 into 15, okay, 2 into 15. So clearly when we split the 17 in terms of 2 and 15, we get 2 plus 15 is 17, and 2 into 15 is 30. So both these conditions are satisfied. So the product of the two numbers that we split into should add up to the term b, should add up to the middle term, and the product should equal to the product of a and c. In this case, a and c are 6 and 5, so the product is 30. So 2 into 15 is 30. So we will split the middle term as per these two numbers, 2 and 15. So we'll write this as p of x equals 6x squared plus 17x. We are going to write it as 2x plus 15x. Okay, so it's still 17x, right? 2x plus 15x is 17x. We have just split the middle term. So I'll split the middle term here as 2 plus 15, and then you have the rest of the terms as they are, so plus 5 as it is. So now we will take some common terms, common factors from this expression, and then simplify it. So if we look at this, the first two terms, what is the common factor that we can take out from these first two terms? We have 6x squared and 2x. So 2x can be taken out as a common factor. So we can take 2x out as a common factor. And what should we multiply with 2x to get 6x squared? So we should multiply it with 3x. So 2x into 3x will be 6x squared, plus with what number? If we multiply 2x, we'll get back 2x. That should be 1. So 2x into 3x plus 1. So 2x into 3x is 6x squared, plus 2x into 1 is 2x. So we have got the first two terms. And then what we do is, whatever the term we have got inside the bracket, we'll just repeat it for the next term. So we will get the same 3x plus 1. And then we have to multiply with whatever term to get the remaining two terms. The remaining two terms are 15x plus 5. So with what number, if we multiply this term inside the bracket, we will get plus 15x. So that will be plus 5. So plus 5 into 3x will be 15x. And plus 5 into plus 1 will be plus 5. So now we have the entire expression obtained. So 2x into 3x is 6x squared, plus 2x into 1 is 2x, plus 5 into 3x is 15x, plus 5 into plus 1 is plus 5. So we have all the terms that are in our original expression for the polynomial. So now we have in this last expression, 3x plus 1 is a common factor in both the terms. So we will take the 3x plus 1 out as a common factor, and then we have 2x plus 5. Okay, so basically we have taken 3x plus 1 as a common factor because it is present in both these terms. So we have taken it out as a common factor. So this 3x plus 1 is multiplying this 2x, and this 3x plus 1 is multiplying the 5. Okay, so we have 3x plus 1 plus 2x plus 5. So these are the factors of the polynomial p of x. So we have seen how to get the factorization done for a quadratic polynomial by splitting the middle term. So just to reiterate, let me repeat the process. We have to split the middle term in such a way that the product of the two terms that we have should be equal to the product of a and c. In this case, a and c have a product of 30. 6 into 5 is 30. And the sum of those two numbers should give us the middle term. So 2 plus 15 is 17. So we split it in that particular fashion. So we split the middle term according to these two numbers. So 17x is basically 2x plus 15x. Okay, so 2x plus 15x, 2 into 15 is 30, and 2 plus 15 is 17. And once we have done that, we just apply some algebraic rules so to take the common factors out. And then finally we obtain our factorization for the given polynomial. And suppose we had to take this one step further and had to find the zeros of the polynomial. So zeros of p of x. I'm just doing this as an extra. Zeros of p of x. How to get them? So we just have to equate the factors to 0 and find the values of x. So the first factor is 3x plus 1. And we equate that to 0. So x or 3x will be minus 1. So we take the 1 to the other side, we get minus 1. And therefore we will have x equals minus 1 over 3. So that's 1 0 of the polynomial p of x. The second 0 of the polynomial, we take the second factor and equate it to 0. So the second factor is 2x plus 5. Equate that to 0 and solve for x. So that will give us 2x equals, we take the plus 5 to the other side, we'll get minus 5. And now we take the 2 to the other side. So the 2 is multiplying on this side. So when it goes there, it will divide. So it's minus 5 by 2. So we have the zeros of p of x as minus 1 by 3 and minus 5 by 2. And the factors of p of x are 3x plus 1 and 2x plus 5. So these are the two factors of p of x. So let me write that as well. With a different color here. So I'll write here factors of p of x are 3x plus 1 and 2x plus 5. So we have these two factors for the given polynomial, 6x squared plus 17x plus 5. Okay, so this method sometimes is easier than finding the factors using the factor theorem. So let's compare how we can get the factors of this of the same polynomial using the factor theorem, and we will notice that factorizing using using the method of splitting the middle term is much easier in this particular case. So let's factorize the same polynomial now using the factor theorem and see the difference between the two methods. So now to factorize this using the factor theorem, I'll just divide the page into two parts here. So we can write this p of x. So we know when doing it with the factor theorem, we want to get this polynomial represented with the value of a as 1. So we'll take the 6 as a factor, as a common factor outside, and rewrite this expression by taking the 6 outside. So we can write this p of x as, if I take the 6 outside as a term, then we'll have x square. There's no 6 here, so we'll divide the 17 by 6. So 6 into 17 by 6x. So when we multiply these two terms now, 6 into 17 by 6, 6 and 6 will cancel, and we'll have only the 17x plus this will also be 5 over 6. So this is our first step. So we'll take the 6 out. So now we have this in some form like let's say 6 into I'll call this as g of x. Okay, so g of x here is x squared plus 17 by 6x plus 5 by 6. Now let's say this g of x, this polynomial g of x, which is inside the bracket, it has factors a and b. It has let's say zeros a and b. So once if you know the zeros of the polynomial, then x minus the 0 gives us a factor of the polynomial. So let's say suppose a and b are zeros of g of x. Okay, then we can write the p of x as 6 times g of x, 6 times g of x, which is 6 times x minus a, because a is a 0 of the polynomial g of x. So therefore x minus a is a factor of the polynomial g of x. Okay, similarly, if we have b as a 0 of the polynomial, then x minus b will also be a factor, so we can write into x minus b. So we can write this in this form, 6 into x minus a into x minus b. So the question now is, how do we find the values of a and b? So since a and b are zeros of the polynomial g of x, so basically we have to find these values by trial. So we have to substitute various values in place of x and see with what value we get the value of g of x evaluate to 0. So we can try to put 0 in this expression. If we put x equal to 0, we'll get 0 plus 0 plus 5 by 6. So that is not equal to 0. So we have to keep doing this by trial and error. So that's the difficulty of this method. Unlike the splitting the middle term method, where we can proceed in a very logical way, here we have to do some trial and error to see what are the zeros of the polynomial g of x. So by trial, we have found out that let's say we put g of x equals to minus 1 by 3. Okay, x equals minus 1 over 3. Then we will have g of minus 1 over 3. We will get it as minus 1 over 3 square plus 17 by 6 into minus 1 over 3 plus 5 over 6. So if we simplify this, we will get minus 1 over 3 square is 1 over 9. That will be minus 17 over 6 into 3 is 18, and that will be 5 over 6. So we can take the LCM. So LCM for these three numbers, 9, 18 and 6, is going to be 18. And then on the numerator we will have 9 goes into 18 two times, and 2 into 1 is 2, minus 18 goes into 18 one time, and 1 into 17 is 17, plus we will have 6 goes into 18 3 times, and 3 into 5 is 15. So we have 15 plus 2, 17, minus 17 equals 0. So that is equal to 0. Okay, so one of the zeros of the polynomial is x equal to minus 1 over 3. Again, this is something we have to do by trial method. So we have to just keep substituting different numbers in this expression. X equal to 0, 1, minus 1, plus 1, 2, 3, or 1 by 2, 2 by 3, 1 by 3, and so on, right? So by doing a trial of different numbers of x, we will eventually find out with what value of x the polynomial evaluates to 0. Okay, so we get g of minus 1 by 3 is 0. So therefore x equal to minus 1 by 3, minus 1 over 3 is 0 of g of x. So therefore x plus 1 over 3 is a factor. Let me write that clearly, is a factor of g of x. Again, by trial we have to find the second 0. So one of the 0, which is a, is minus 1 over 3. So x minus over 3, we get x plus 1 over 3 as a factor. And similarly, by trial we have found that the second 0 is x equals minus 5 over 2. So when we substitute x equal to minus 5 over 2 in the expression for g of x, so this will be minus 5 over 2 square plus 17 by 6 into minus 5 over 2 plus 5 by 6. So that gives us 25 by 4. Plus into minus will be minus 17 into 5. So 17 into 5 is 85 divided by 12 plus 5 over 6. So the LCM in this case is clearly going to be 12. So the LCM of 4, 12 and 6 is 12. So 4 goes into 12 3 times. 3 into 25 is 75. Minus 12 goes into 12 one time. 1 into 85 is 85. And 6 goes into 12 2 times. So 2 into 5 is 10. So we have 75 plus 10 is 85 minus 85, which is 0. Okay, so therefore we have x equals minus 5 over 2 is 0 of g of x. Therefore we'll write x plus 5 over 2 is a factor of g of x. So overall we have this p of x as 6 times g of x, which is 6 into the first factor x minus a and the second factor x minus b. So overall we can write this as so therefore we'll write p of x equals 6 into x minus 6 into x minus minus 1 by 3, which is x plus 1 over 3 into x plus 5 over 2, right? And when we simplify this, we will get back the same answer that we have in the previous case as 3x plus 1 and 2x plus 5. Let's see how we can get that. So basically I'm going to draw a line. I'm out of space for this page, so I'll just draw a line here and do the continuation over here. Okay, so let me do one more step on this page itself. So we can write this as 6 into if we take the 3 as the LCM here, so we'll get 3x plus 1 over 3, and similarly here if we take the 2 as the LCM, we will have 2x plus 5 over 2. So now I'll just do the continuation over here. We have 6 into 3x plus 1 into 2x plus 5 divided by 6. So we get 6 into 3x plus 1 into 2x plus 5 divided by 6. In the denominator we have 3 and 2, so 3 into 2 is 6. So we'll have the 6 and 6 cancelling out each other, and we will be left with only the 3x plus 1 and 2x plus 5 terms. Okay, so 3x plus 1 into 2x plus 5, okay, which is the same answer we had on our previous method. So 3x plus 1 into 2x plus 5, those were the factors of the polynomial p of x, and we have obtained the same answer as the factors for the polynomial p of x using the factor theorem. But you can see that the factor theorem in this particular case is not so easy, because we have to find out the zeros of the polynomial, and this has to be done by trial. For this illustration purpose, I have given these values in the discussion here, but if we did not know these values, then we have to substitute various values in this x and figure out for what value of x this expression evaluates to 0, and that could be a lengthy process, and it makes the factorization more difficult, okay, especially when you have expressions which are having the coefficients as fractional numbers. Finding the zeros can be a bit tricky, okay. So in this case, the method of splitting the middle term, which we saw earlier, which is this method, is much simpler and shorter as compared to the method of using the factor theorem, okay. So this is one way of splitting or factorizing the quadratic polynomial, okay, using the method of splitting the middle term. So let's do one more example and also compare this example by using the factor theorem. So we'll again do both the methods using factor theorem and also by using the method of splitting the middle term. So let's first do for this polynomial y squared minus 5y plus 6, factorizing this using the factor theorem. So for factorization, what we do is, again, one small hint that we might get in choosing the values for y, or the zeros, or in finding the zeros of the polynomial, is to use the constant term 6. So if we write down what are all the different factors of 6, so the factors of 6 will be so let me write that. Factors of 6 are 1 is a factor of 6, 2 is a factor of 6, and 3 is a factor of 6. Of course, 6 is also a factor of 6, but we want to keep only those numbers which are below 6. So 1, 2, and 3 are the factors of 6. And let's see if any of these factors of 6 happens to be a 0 of the polynomial. So if we put p of 1 and see what happens. So in place of y, we put 1, so it's 1 square minus 5 into 1 plus 6. So we get 1 minus 5 is minus 4. Minus 4 plus 6 is basically 2, okay. So this is not equal to 0. Therefore, 1 is not a 0 of this polynomial. Similarly, we can check p of 2. So for 2 now, it will be 2 square plus 5 into 2 plus 6. It's a minus here, okay. So it's minus 5 into 2. So we get 2 square is 4. 5 into 2 is 10. So minus 5 into 2 is minus 10 plus 6. So we get this as 0. 4 plus 6 is 10. Minus 10 is 0. So that means 2 is a 0 of the polynomial. So therefore, x equals 2 is 0 of this p of y. And similarly, let's check for 3. P of 3 will be not x equal to 2. In this case, the variable is y. So I'll have to write this as y equals 2 is 0 of p of y. And similarly, if we evaluate p of 3, we are going to get in place of 3 y we put 3, so 3 square minus 5y plus 6. So no, I have to put the value of y, so 5 into 3 plus 6, so 3 square is 9, minus 5 into 3 is minus 15 plus 6, so 9 plus 6 is 15, and 15 minus 15 is 0. So therefore y equals 3 is 0 of p of y. So if y equals 2 is a 0 of p of y, and y equals 3 is also a 0 of p of y, then we can say now y minus 2 and y minus 3 are factors of p of y. Okay, so therefore we can write our p of y equals y square minus 5y plus 6 as a product of their factors, which is y minus 2 into y minus 3. And clearly if we multiply these two terms, you will see that you'll get back this expression. So y into y will be y square, minus 2 into y is minus 2y, and minus 3 into y is minus 3y. So minus 2y minus 3y will be minus 5y, and minus 2 into minus 3 will get back the plus 6. Okay, so when we multiply these two factors, we'll get back the original polynomial. So clearly we have been able to factorize it. In this case, however, it was much easier compared to the previous example of factorizing using the factor theorem. So in some cases, factorizing by finding the zeros of the polynomial can be tricky. Sometimes it might be easy, but in some cases it is easier to do it by splitting the middle term. So let's do the same problem here by splitting the middle term, and we'll find out how it compares with factorization with the factor theorem. So again, I'll write down p of y, which is equal to y square minus 5y plus 6. So now we have to split this middle term minus 5y such that the two numbers in which we split it have a product of the coefficient of y square and the constant term. So the coefficient of y square is 1 here, so 1 into 6 is 6, and when we add those two numbers we should get minus 5. So we want to split this in such a way that the sum of those two numbers is minus 5 and the product is 6. Okay, so how did we get the product as 6? Because it's 1y square plus 6 here. Okay, so a into c, ay square plus by plus c. So a is 1, b is minus 5, and c is 6. So a into c is 6. 1 into 6 is 6, and we have b as minus 5. So we now need to find two numbers whose product is 6, and when we add them, whose product is plus 6 to be specific. Okay, don't forget the sign. So it is 6 with a plus here. So plus 1 into plus 6 is 6, and we add them when we add them algebraically, we should get the sum to be minus 5. So what are the two numbers in which we can split this? So what are the two numbers whose products can be 6? So you can have 6 into 1 as 6, but if we add 6 and 1, can we get minus 5? We can get minus 5 if we have minus 6 plus 1. When we have minus 6 plus 1, we'll have minus 5, but minus 6 into plus 1 will get minus 6, but not plus 6. We need a plus 6. So what is the other way? We can have 3 and 2. Okay, so we can have 3 and 2. 3 into 2 is 6, and we need the minus 5. So 3 plus, if you use plus 3 and plus 2, we will get plus 6, but we will not get minus 5. So what we can do now, let's try minus 3 and minus 2. So if we split this as minus 3 and minus 2, so minus 3 into minus 2 will be plus 6, and minus 3 minus 2 is minus 5. Okay, so that's the final way of splitting it. That would be the correct way of splitting it. So we have to find the numbers into which we can split this middle term such that their product is equal to the product of A and C, and their sum is equal to the value of the coefficient B. Okay, so in this case the numbers turn out to be -3 and -2. So we can now write this expression as y square, and minus 5y we can write it as minus 3y minus 2y. So we have split the middle term minus 5y based on these two numbers. So minus 5 is minus 3 minus 2. So minus 5y is minus 3y minus 2y and plus 6. Okay, now it is just a case of simplifying it by taking some common factors. So for the first two terms, what is the common factor that we can take outside the bracket? We can take only y as a common factor, so we'll take y as a common factor outside, so it will be y minus 3 inside the bracket. So now y into y is y square minus y into 3 is minus 3y. Okay, minus y into 3 is 3y, so we have y into y minus 3, and we will use this y minus 3 which is inside the bracket one more time here. So we'll have the same term here, y minus 3, and now we have to see with what term, if we multiply this y minus 3, we get the remaining part of the expression. So clearly we have to multiply this with minus 2. So when we multiply this with minus 2, will be the product now will be minus 2 into y is minus 2y, and minus 2 into minus 3 is plus 6. So now we have it in this form, and now we can take the y minus 3 as a common factor, and we will be left with y. So when we take the y minus 3 as a common factor in this entire expression, so this is multiplying the y, so we have that y, and this is multiplying the minus 2, so we'll have the minus 2. Okay, so basically we have got back our factorization as y minus 3 into y minus 2, which is the same answer we had here. Okay, y minus 3 into y minus 2. So since it's a product, we can write the product either way. 2 into 3 or 3 into 2 is the same, right? So y minus 3 into y minus 2 or y minus 2 into y minus 3, either way is the same. So we got back our factor. In this particular case, we use the method of splitting the middle term. Okay, now that we have a clear understanding of how to do factorization using the method of splitting the middle term, let us do some exercise problems using this method. The factor theorem method is something we have seen in the previous video as well, and we have seen that the factor theorem method is actually quite lengthy because we need to find the zeros by trial. Once we find the zeros by trial, and then we can find the factors. But since we have to find the zeros by trial method, it can be a lengthy process at times. So in the exercise problems, we will be solving or factorizing the expressions only by using the method of splitting the middle terms, so we can re-emphasize what this method is. Okay, so let's start with our first exercise problem. So we are given the polynomial 12x squared minus 7x plus 1. So we need to split this middle term. So the middle term here is minus 7x. So we need to split this in such a way that the numbers that we choose for splitting should have a product of a and c. In this case, a is 12 and c is 1. So 12 into 1 should be 12. So I usually do this in this way. So the product should be 12, and don't forget the sign. Okay, it is plus 12 into plus 1, so it is plus 12. So when it's plus, I'm not writing it, but if it's minus, we have to write that. Okay, and when we add those two numbers, we should get minus 7. So what two numbers we can choose such that their product is 12 and their sum is minus 7? So for 12, we can have 2 into 6. If we have 2 and 6, 2 and 6 will never add up to 7. Similarly, we can have 3 and 4. 3 and 4, 3 fours are 12, and 3 plus 4 we can get it as 7 by choosing the appropriate sign. Or we can have 6 into 2. So 2 into 6 doesn't work, so therefore 6 into 2 also will not work. Then the fourth option is 12 into 1. By using 12 and 1 we cannot get the 7. 12 into 1 will be 12, but by adding 12 and 1 we can never get 7. So the only option that is left for us is to use the numbers 3 and 4, with the correct sign such that the product becomes 12 and the sum becomes 7. So if we leave both as positive, 3 into 4 is 12, plus 3 into plus 4 is 12, that's okay. But 3 plus 4 is plus 7. We need minus 7. To make it as minus 7, what we do is we will put a minus in front of both. So minus 3 into minus 4 is plus 12, and minus 3 minus 4 is minus 7. So the middle term of minus 7x will be split according to these two numbers, minus 3 and minus 4. So we will write this as p of x equals 12x square minus 3x minus 4x plus 1. Okay, so once we have this, we can now simplify it by taking a common term. So what is the common term that we can take here? We can take 3x as the common term, and 3x with what factor we have to multiply to get 12x square, so that should be 4x. 3x into 4x, 3 into 4 is 12, x into x is x squared, so we get 12x squared and minus 1. So 3x into minus 1 is minus 3x. So we now have the term inside the bracket as 4x minus 1. So we'll reuse that same term, 4x minus 1. And with what number, if you multiply the 4x minus 1, we will get the second half of this expression. We need minus 4x plus 1. So clearly we have to multiply it with minus 1. So minus 1 into 4x will give us minus 4x, and minus 1 into minus 1 will become plus 1. Okay, so now we have the 4x minus 1 as the common factor, which multiplies 3x minus 1. So the factors are factors of p of x equals 12x square minus 7x plus 1 are 4x minus 1 and 3x minus 1. Okay, so these are the two factors of the quadratic polynomial, 12x square minus 7x plus 1. So basically, if you multiply these two terms, you will get back the polynomial. So 4 into 3 is 12x into x is 12x square. 4x into minus 1 is minus 4x. Minus 1 into 3x is minus 3x. So minus 4x minus 3x, we will get back our minus 7x. And minus 1 into minus 1, we will get plus 1. So when you open this brackets, you will get back the expression. Okay, so the factors of this polynomial are 4x minus 1 and 3x minus 1. And if we had to find the zeros of the polynomial, we just have to equate the factors to 0 and solve for x. So if we solve for this to 0, equate this to 0 and solve, we will get x equal to plus 1 by 4, and in this case x equal to plus 1 over 3. Okay, again, that is if we need to find the zeros. Okay, let's keep our attention fixed to finding the factors only for now, and move on to the next question in the exercise, which is the exercise number 2.3. And this is question number 4. Okay, question numbers 1, 2 and 3, we have solved it earlier for this exercise in the previous video, where we were using the factor theorem and remainder theorem. And question number 4 deals with factorization of the quadratic polynomial using the splitting method, using the method of splitting the middle term. So let's do the second question. So we have p of x is given by 2x squared plus 7x plus 3. So how do we split this? So we need to split this middle term, which is 7 plus 7x, such that when we add the two numbers, we should get 7, and when we multiply the two numbers, we should get 2 into 3, which is 6. The product of the coefficient of x squared and the coefficient of the constant term, which is 3. So 2 into 3 is 6. So we should split it such that the product is 6 and the sum is 7. So what two numbers we can use such that when we multiply them, we should get 6, and when we add them, we should get 7. For 6, we can use 6 into 1. So 6 into 1 will give us 6, and 6 plus 1 will give us 7. So that seems to be correct. Or we can have 2 into 3. 2 into 3 is 6, but 2 plus 3 will not give us 7. So we cannot use 2 and 3 or 3 and 2 also. So the only option is 6 into 1 or 1 into 6. Okay, so we'll go with 6 and 1. So we clearly have 6 into 1, we get 6. So the product of these two numbers is 6. And the sum of these two numbers, which is 6 plus 1, we get 7. So we will split the middle term as per these numbers as 6 and 1. So we will write our P of x as 2x square plus 6x plus x. So we are splitting the middle term 7x as 6x plus 1x. So 6x plus 1x, 1 we don't write here, 6x plus x. Okay, and then we have our term 3. So now we just have to take some common factors out and simplify this expression. So we will take let's say 2x as the common factor. So 2x into x will give us 2x square, and with what number, if we multiply 2x, we'll get 6x. So that should be clearly 3. So 2x into x plus 3. So 2x into x is 2x square, and 2x plus into plus 3 is 2 into 3 6, and x we have 2x into 3 is 6x. And now we will take this x plus 3 again and find out with what number, if we multiply this x plus 3, we get the second half of this expression. So clearly we have to multiply this expression with plus 1. So plus 1. So plus 1 into x will be plus x, and plus 1 into 3 is plus 3. So now we can take the x plus 3 as the common factor in this entire expression into 2x plus 1. Okay, so now we have these two monomials as the factors of the quadratic polynomial. So therefore factors of P of x equals 2x square plus 7x plus 3 are x plus 3 and 2x plus 1. And again, if you want to find the zeros of P of x, just equate this to 0, the factors to 0, and solve them, and solve for x. So if I make x plus 3 equal to 0 and solve for x, we'll get x equals minus 3. Similarly here, 2x plus 1 equated to 0 and solve for x, we'll get x equals minus 1 over 2. So those will be the zeros of this polynomial. Okay, of course, that is not something we're focusing here. So the factors are x plus 3 and 2x plus 1. Okay, so we have seen that the method of splitting the middle term is fairly straightforward. The only thing we have to do is to find the two numbers whose product is equal to the product of a and c, and their sum should be equal to the middle term, which is b. Okay, so let's do the next example, or the next question. So we have 6x squared plus 5x minus 6. So the product of the two numbers that we will use to split the middle term, so our middle term is plus 5x. So we need to split this in such a way that the sum is plus 5, so that's the middle term, and the product should be 6 into minus 6. Okay, because we have a is plus 6 and c is minus 6, so 6 into minus 6 is minus 36. So we need to choose two numbers such that their product is minus 36 and their sum is plus 5, and that is how we are going to split the middle term. So we need to think about two numbers whose product will give us 36, minus 36, and the sum should be 5. So we can have 36 into 1, that will never make it 5. We can have 12 into 3, but when we add 12 and 3, even with any combination of signs, it will never give us plus 5. Or we can have 4 into 9, or 9 into 4. So 9 and 4 seems plausible here. So let's use those numbers. We'll have 9 and 4. So using the combination of 9 and 4, we can have the value of 5 by putting a minus sign in front of one of those numbers. So if I put a minus sign in front of 9, minus 9 into plus 4 will give us minus 36, but minus 9 plus 4 will give us minus 5. But we want a plus 5 here, so the correct way would be to put a minus sign in front of the 4. So now we have 9 minus 4 is 5, and 9 into minus 4 is minus 36. So 9 4s are 36, and one of the numbers is negative, so it's minus 36. So you can split this using these two numbers, which is 9 plus 9 and minus 4. So let's go ahead and do that. So we can write our p of x as 6x squared plus 9x minus 4x minus 6. Okay, so now we just have to take some common terms. So between 6x squared and 9x, what is a common term we can take out? We can take out 3x as a common term. If we have 3x as a common term, 3x into 2x will give us 6x squared, and 3x plus what will give us 9x, plus it has to be 3. Okay, 3x into 3 is 9x. So we'll have 3x into 2x is 6x squared, plus 3x into 3 is 9x. So we'll use that same term, 2x plus 3. And now with what number, if we multiply this expression, we will get the second half of the polynomial. So clearly we have to multiply this with minus 2. So we'll have minus 2 into plus 2 is minus 4, and then we have an x. So minus 2 into 2x is minus 4x, and minus 2 into plus 3 is minus 6. Okay, so we have now 3x into 2x plus 3 minus 2 into 2x plus 3. So we can now take the 2x plus 3 as a common factor, and then we'll have the remaining term, which is 3x minus 2. So 2x plus 3 and 3x minus 2 are the factors of p of x. So we'll write factors of p of x are 2x plus 3 and 3x minus 2. Okay, so we have found the factors, and clearly we see that the procedure for factorizing by splitting the middle term is fairly easy and quick. The only part is to find these two numbers whose product is equal to the product of a and c, and the sum is equal to the middle term, which is b. Okay, so that's the third question. We'll do one more question. There is one more question in the exercise. We'll do that as well, and then we'll finish this lecture. So the final problem is we have 3x squared minus x minus 4. So again, now we are going to use we are going to split the middle term, which is this middle term. We need the middle term is minus 1. So since it's minus x, it's minus 1. So we need to split this in such a way that the sum is minus 1 and the product is equal to 3 into minus 4. So 3 plus 3 into minus 4 is going to be minus 12. So we need to find two numbers whose product is minus 12 and whose sum is minus 1. So what two numbers will give us a product of minus 12? We can use 12 and 1. So 12 and with one of them as a negative number, we'll get minus 12. But with 12 and 1, we will never get minus 1. Okay. Similarly, we can use 6 and 2. So 6 into minus 2 or minus 6 into plus 2 will give us minus 12. But 6 and 2 will never add up to minus 1 with all possible combinations of the signs. So the next option is 3 into 4. So I think that looks like a plausible answer. So we will have 3 and 4. So we need to put a negative sign in front of one of these numbers, because 3 and 4 add up to have a product of 12. So if I put a minus in front of one of those numbers, we'll get minus 12. But we need to put a minus in such a way that when we add those two numbers, we should get minus 1. So if we put a minus in front of 3, Minus 3 into 4 is minus 12, but minus 3 plus 4 is plus 1. So we need minus 1, so we'll put the minus in front of the 4. So now we have 3 and minus 4. So 3 into minus 4 is minus 12, and 3 minus 4 is minus 1. So we can split the middle term minus x as plus 3x minus 4x. So we'll do that now and proceed with our factorization process. So we'll have p of x equals 3x square plus 3x minus 4x minus 4. So clearly 3x minus 4x is minus x. Okay, so we just split this middle term as per these numbers, and then we will simplify this. So between 3x and 3x square and 3x, what is the common factor we can take out? We can take 3x outside, and 3x into x will give us x square. So 3x into x will give us 3x square, and we have a plus sign. Plus 3x into what number will give us the second term, which is this term, so that should be 1. So 3x into 1 is 3x, and we will repeat this x plus 1 again, and we'll figure out with what number, if you multiply this term in the bracket, we will get the second half of the expression. So clearly it is going to be minus 4. So minus 4 into x is minus 4x, and minus 4 into plus 1 is minus 4. So now we can take the x plus 1 as the common factor, and we will have 3x minus 4. So clearly our factors are factors of p of x equals 3x square minus x minus 4 are x, let me write that clearly, x plus 1 and 3x minus 4. Okay, so we have done the factorization now, and the factors of this quadratic polynomial are x plus 1 and 3x minus 4. Okay, so we have seen a few examples of how to factorize using the method of splitting the middle term, and this method applies for the quadratic polynomials. When you say quadratic polynomials, we mean that the degree of the polynomial is 2. That means the highest power of x is 2, and this method is used to factorize quadratic polynomials. Okay, we will stop here for now, and we will continue our discussion of factorization of polynomials in the next video, where we will talk about factorizing cubic polynomials, that is polynomials whose degree equals 3. That means the highest power of x is equal to 3, so we call such polynomials as cubic polynomials, and we will see how we can factorize the cubic polynomials. And what we will see is that in the process of factorization of the cubic polynomial, we will split the cubic polynomial into, in the first step, into two terms. One will be a monomial, which is a polynomial with degree 1, and the other will be a quadratic polynomial, which is the polynomial with degree 2. So after splitting it into a monomial and a quadratic polynomial, we will then split the quadratic polynomial further using the method of splitting the middle term. So we will first factorize the cubic polynomial into two different polynomials. One will be a polynomial with degree 1, and the other will be a polynomial with degree 2, and then we will further factorize the polynomial with degree 2 to get the complete set of factors for the cubic polynomial. Okay, we'll stop here for now, and we'll continue the factorization of cubic polynomials in our next video.